Welcome to the fourth part of our Python tutorial. In this part, you will learn about functions, how to write your own functions or how to read functions that somebody else has written. We will start with a mathematical example and then to get to a hopefully more entertaining example with words. So when do you want to write your own function? You want to write your own function when you do something more than once so that you can reuse your code. Sometimes you also want to write your own function that your code is structured better, that it's easier to read, so that you don't have one long script, but that you define task by task, each task as a short task, and then just call the tasks one by one. So for example, if you want to have a function for brushing your teeth, then you don't want to write the details of how to squeeze toothpaste out of the tube. You want to have one sub-function that does that for you so that you get a good overview of your code in general. So much about advertisement for using functions, and use functions to get more beautiful code, use functions so that you don't need to repeat what you type. So in this example, we write a short function, and that short function shall just calculate a second order polynomial. So for some reason, we are very interested in second order polynomials for this example. So we define a function and we give it a name. The name for that is SOP. It's not a good name because nobody would know what SOP stands for, but it's short to type. So for this example, it's okay. So we have a function called SOP, and its parameters are x, x0, x1, and x2. So it has 4 parameters. The parameter names are important for my function definition right here. So everything that's indented, again, that's similar to loops and if else, everything that's indented is part of my function. And I define a variable called y, and y shall be x2 times x to the power of 2. Those 2 asterisks means to the power of. So x2 times x to the power of 2 plus x1 times x plus x0. So that's the definition of a second order polynomial. And then in this line, I say return y. Return means return this variable as output and then stop execution of the function. So if I continued writing below that line, it will never execute it. So here I say the output of my function is y, and that's what is returned. So my function has 1 output, and it has 4 input parameters. And in the following, for that code, we will just pass some parameters and always obtain the output and print it directly. So here I create 3 variables, a, b, and c. And then I print SOP of 1, a, b, and c. So I have only a c equals 1 here, and c is the 4th parameter here. So the 4th parameter is my x2. So my x is here 1, and then my x2 is also 1. The other 2 are 0. And I do that computation here. So x2, my c equals 1 times 1 to the power of 2. So y should be 2 in the first. Y should be 1 in the first run. And so on. And then I have x equals 2 with the same parameters, x equals 3. So I just get x squared basically by this code. Here I have a, b, and c. Here I have x0, x1, and x2. What does this mean? So these names here are only important for the function declaration. So the names here in the function declaration are where I define my function, where I write my function. But then I can pass any variable that I have defined as parameters in my code here. So I don't need to agree with the programmer that wrote that function. I can pass any parameters. For example, if you use the built-in square root function, then whoever implemented that might have written square root of x, but you want the square root of a, so you pass parameter a, and that is the same here. So we have defined here x, x0, x1, and x2 for writing our function. Then in our code, they might have different names, and it depends on the position of the parameter, what's done with it. So the first is the x, the second is the x0, and so on. And then I print all of them. And then in the next examples, I change my B and my A, and I just, again, I print it several times. And then I get an output. So as I've said, first I expect just x squared because a and b are 0. So it's 1, 4, and 9. X was 1, 2, and 3, and then some other silly examples where I have a b and an a, and those are all second order polynomials. You can calculate that. I should add one more line for function because that's actually quite important. So the output value can be assigned to a new variable. So I could name my variable whatever, let's call it s, and I could say s equals SOP of 1, 2, 3, 4, whatever I want to pass to that. And then I create a variable called s, and s is assigned with the output of SOP of that. I won't print it, but now it will have some value, and it's 9. Yep, so much about the basics of functions. This function definition is obviously about numbers. I multiply, I have something to the power and plus, but I could also give it other variable types. For example, I could give it an array. So for having an array, I use NumPy to define my array, as we've learned 2 lessons ago. So I import NumPy as np, then I call np arrange, which gives me an array with 10 elements, 0, 1, 2, 3, 4, 5 until 9. I print that so that you show what x is. And then I call the function SOP on that x and what my previous values for a, b, and c were. So b is still 3, a is -2, and c is 1. Just to show that I can call this function on an array. And I call it on the array 0, 1, 2, 3 up to 9. And then it also gives me 10 outputs. So it works with an array as the first input character and with scalars a, b, and c. So just a single number as the other input vectors. And why is that the case? Why does it work now for arrays when I on first just wanted it as it integers? Well, this happened just by chance right here. That is because all the operators, that multiplication and that power, they all work with arrays and between arrays and scalars. So the whole function works with that. And again, I have one output variable. That's still my y, but y quite automatically, because of this line with the given inputs, y becomes an array, and this array is now my output, and I print this output here. So what the function actually does depends on the type of the input. As long as all the operations inside the functions are defined for all my inputs and the combination of those inputs, those functions will run. So for example, if I define a very simple function, just add x and y, then I could run that for numbers, obviously, and would add those 2 numbers. But x and y could also be strings, and then it would, as we have seen before, just concatenate those 2 strings. So what actually happens is defined as runtime and not when we write it. So as promised, I hopefully slightly more entertaining example. Let's assume I often need to write short messages, and I call that function print letter. So I often want to write short messages, and because I want to be polite, I want to write something like dear best friend, and then a text body, and at the end I want to add a signature and a greeting. So I define a function print letter. The input parameters, I now have 5 input parameters. The first is called recipient. The second is called sender. And what I do here, I give a default value for sender. So default value for sender is now Joseph. And the same happens for the third parameter, a variable called greeting. I give it a default value. So the greeting is high on default, and then the signature also has a default, and the text body also has a default. And all what this function does, it just prints something on the screen. And those default values are very good because it has 5 input parameters, but because of having the default values for the second, third, fourth, and fifth input parameter, I actually only need to pass a recipient for that function to work, which I do here. I call my function print letter and only pass it the recipient John, and then the sender is Joseph, the greeting is hi, the signature is best wishes, and the body is I'm sorry that I cannot attend today's Zoom meeting, and it executes that code below here, and the result is hi John. Then I add a greeting hi plus John, and I add a line break, and then I print the text body, and again after the text body I add an extra line break by this special character, then I print my signature and the sender. So the result is hi John, I'm sorry that I cannot attend today's Zoom meeting, best wishes Joseph. So the take-home message from this snippet of code is parameters can have default values, and if I don't pass that parameter, then they take the default value in that function. So what I could do again, I could call that function again, and here I pass 4 but not 5 parameters. So what will happen? So I've defined now the recipient called Prime Minister. The sender is Joseph. I defined it again. Why do I define Joseph again? Because I want to change the third parameter. So I have, in this example, to give the second parameter as well. And I give the fourth parameter as yours sincerely. I don't give a fifth parameter. So the fifth parameter will be my standard text body. The result is dear Prime Minister, I'm sorry that I cannot attend today's Zoom meeting. Yours sincerely, Joseph. So I can, by using this method of passing the parameters by position, I can just drop the last parameters if they have a default, and then it will take a default. But sometimes functions have much more than 5 parameters, and I want to use the default value for most of the parameters. One example is, for example, functions to plot something. So packages that allow us to plot something, they have numerous parameters for text color, line width, and so on, and I only want to change a few, and it would be tedious to list all of them if I just need to change the 19th one or so. That's why Python has a much better method of how parameters are passed to functions, and that is not passing by position, but passing by name. And that's what I do in this last but the important example here. So I call my function print letter, and I pass it the recipient, because I always need to pass the recipient that doesn't have a default value. So I say the recipient is a string called, and a string with the content darling. And then I also pass another body, I love you. And then I can execute this one. So the output is the default for the greeting hi, and hi darling, another text body, I love you. And maybe I should have changed the best wishes as well. But the take-home message of this is, so passing by name is quite a powerful concept if you want to take many of the default values of a function and only want to change a few. Then when you call that function, use passing by name and change those parameters that either don't have a default or for whom you want to change from the default. So that's basically it. This was the fourth short lesson about function. And I think with those 4 examples, you know the most important bits of Python already. The next one will be about classes.